Okay, here we are, part 3. This is our last part of this set of notes. Objective 3 is to understand that a function has two sets, the domain and range, and each element of the domain is assigned exactly one element of the range. So I'm going to have you look at this website on domain and range, and it explains basically what I talked about in part 1. The domain is all your x values on a graph, and your range is all your y values. Let's see. Here's some more examples that we talked about at the beginning of mapping. A codomain is what may possibly come out of a function. Okay, that's not something that we're technically going to be talking about or using. I don't believe it's in your diagnostic or your focus area. So we don't need to worry about a codomain. But again, this talks about using the function machine. So if you were still needed a little help on that, please look at this. Does every function have a domain? Yes, but it's simpler mathematics. We never notice this because the domain is assumed. So yes, they all have domains. And that's kind of it for that. So if you want to look at this, you can, to get a better understanding if you weren't understanding domain and range before. Okay. So let's see. What is the domain of graph H? So the domain is our x values again, okay? So let's look. Our first point starts at -5, and then it goes all through here, and then our last point ends at +5. So let's see. We have not over there. Let's see over here. All right, so -5, all the points are greater than -5, but less than +5. So that would be our domain. Okay. What's the range? So those are our y values. I'm going to find my lowest point, which is -4, and it goes up through here and then up to +5. So let's see, -4 was our lowest. And then I have -3, 1, and 5. Okay, so we have this one here, but we also have this. And because these are points, I can't say that that the range is all x values between -4 and 5, because there are only points here. So I'm going to use this example here, where it shows -4, -3, 1, and 5. Those are the specific x values, or y values, I should say. -4, -3, 1, and 5. Yep. Okay. Let's look at this one. What is the domain? So that's, again, it's our x values. So we have a -6, a 0, a 2, a 4, and a 7. So I can see that it's already right here. And again, we're finding our range. So we are finding, this is an actual graph, so it's going to be everything that's in between -2 and positive 8. So let's see. Negative 2, and it's less than or equal, or greater than or equal to this x, and it's x is also everything that's less than or equal to positive 8. All right. Is the relation given by the ordered pairs below a function? So is it a function? Let's see. Here, let's find our domain. So that's all of our x values. We have a negative 3, we have a negative 2, we have a 0, negative 2 again, and a 3. So right now I'm already seeing that I have 2 negative 2's that are popping up. And my range is 2, 4, 5, 6, and 8. So I'm looking and I'm saying, well, negative 2 has an output of 4, but it also has an output of 6. We can't have an output we can't have an input with 2 different outputs, remember? So that means that this is not a function, right? So let's see. So this is not a function. Okay. Again, I was talking about mapping before, so this is an example of mapping. I could take all my input, all my x values, and list them here, and then list all my outputs. And if you notice, they're going in numerical order, and then I connect them to where they're supposed to go. So I'm looking and I say, okay, 10 has one output, 20 has one output, 30 has one output, and 40 has one output. So that means that this is a function. Now let's look at this one. I'm seeing right off the bat that 2 has 2 different outputs. So this example is not a function. Now, my favorite, vertical line test. I draw my vertical line, 1 point of intersection. So that means it's a go. It's a good one. So that's a function. This one has 1 point of intersection. So that also is a function. This parabola, which is sideways, when we draw the line, the vertical line, it hits it 2 times. So that means it's not a function. Okay. So let's look at this. We have y is equal to 3 plus 2x. Think of your function machine. When you plug in x, do you get one y value for each one? So we have, let me see if this is, so we have when x over here, this looks like it's kind of blurry. When x is, I'm just going to say negative 1, y is 3. When x is 2, y is negative 2. When x is 3, y is 2. When x is 4, y is negative 1. But it is also 1, 2, 3, 4, 5. So these 2 points here are showing me that this is not a function. Okay. All right, so let's do this. When x is 1, y is 1. When x is 1, y is 2. When x is 2, it is 2. When x is 2, it is 4. So I'm already seeing right now that this is not a function. Oops, you can't see that. This is not a function. And let's look at the graph over here. Let's see. When x is -2, it is also 1, 2, 3, 4, 5, all the way up and all the way down. So this is also not a function. Sorry, this one over here as well. This is a function because when you plug in x into the equation, you're going to get one output all the time. So this is a function. All right, check for understanding for this objective. And then we have our last objective, which is very short. Relate the domain and range of a function to its graph. When finding the domain, remember, the denominator of a fraction cannot be 0 because our domains can also be fractions. The number under the square root must be positive. So this type of graph here means that the function has a square root in it. So here's the function of the graph, y equals square root of x plus 4. The domain of this function is x is greater than or equal to -4. So that's right here. So we have -4, and it doesn't go any less than -4. It only goes, x is only bigger than -4. Enclosed circle on -4, 0 shows that the domain starts at this point. Okay, so here our domain is x is greater than or equal to -4. Continuing with the same graph, we're going to look at what the range is. So the range of a function is the spread of possible y values, minimum y value and maximum y value. Substitute different x values into the expression for y to see what's happening. Ask yourself, is y always positive, always negative, or maybe not equal to certain values? Make sure you look at the minimum and maximum y values. So here, our minimum is at 0. Okay. Draw a sketch. In math, it's very true that a picture is worth 1,000 words. So here is the function of the graph, again, that we were talking about in the previous slide. Notice the curve is either on or above the horizontal axis. Okay, so it's above it. No matter what the value of x we try, we will always get a 0 or a positive value of y. So we say that the range in this case is y is greater than or equal to 0. So it's either equal to 0 or it's greater than 0 because it's going up. Okay, so here I'm going to have you practice writing the domain and your range, just like we were doing here. Okay. This is our domain example, and this is our range example. So you can practice writing those on here. And on your own, you're just going to click here to watch this. If it doesn't work for you, just please let me know and I can try to send you the link, or we can watch it during class. Check for understanding. If you're feeling good, you can click here and go to your summit and take your focus area.